We're going to take a look at a concept of reconstitution in the context of a dosing problem. Many times students struggle with these problems because of the extra information that is in the paragraph. Let's take a look at an example. Our order here is atropine, 200 micrograms subcutaneously stat. Available is atropine with the following information on the label. Reconstitute by adding 1.7 milliliters of bacteriostatic water to yield a total volume of 2 milliliters with a concentration of 0.4 milligrams per milliliter. At the bottom is the actual question. Calculate the amount for one dose. So there's so many numbers, and that's why these problems can be a bit more challenging. When I look at the problem, there's a couple key numbers that I want to focus on. I want to focus on what is the actual order. And so I have the order right here. And then I want to focus on what is available. So when I read the entire paragraph about what's available, I see that it needs to be reconstituted. So let's take a moment and talk through this concept of reconstitution. We're to reconstitute, which means that we have a powder, and we need to add liquid to make it a usable form of the medication. Specifically, we need to add 1.7 milliliters of the bacteriostatic water. So I take a syringe, I add air to the container first, and then I pull out 1.7 milliliters of the bacteriostatic water. I make sure to use sterile technique and all that. Then I add the 1.7 milliliters of the bacteriostatic water to my medication. In my medication vial, there is now the original powder plus the 1.7 milliliters, and together they make up 2 milliliters of fluid. I use the 1.7 milliliters to create the 2 milliliters, and that is the reconstitution process. But thankfully, the manufacturer has figured out, once I follow their directions, exactly how strong the medication will be. And they tell me the concentration or the strength of the med is right here, 0.4 milligrams per milliliter. So to do my calculations, and different people do them differently, but I'm going to use what we call the nursing formula, where we take the doctor's order, we divide it by what we have on hand, and multiply by the quantity that is in. It's very important in the formula that the labels from the desired amount or doctor's order and what we have on hand match. So, filling in, the order was 200 micrograms. Now remember that you're never to use the Greek letter when you handwrite micrograms, so we'll use mcg. What we have on hand is 0.4 milligrams. And those milligrams are in the quantity of 1 milliliter. Now, in order for this formula to work, I have to have matching labels. So I'm going to use my King Henry, and this is just my way of remembering the metric system, died by drinking chocolate milk full of microorganisms. So we want to go from micrograms up to milligrams. So we're going to move our decimal 1, 2, 3 places. So I'll take my decimal here, 1, 2, 3 places. So that means that the doctor's order really is 0.2 milligrams. So I get my calculator, 0.2 divided by 0.4 times 1, and I get my answer of 1/2 milliliter, and we write that in its decimal notation. And so we see from a problem like this, we don't actually use the reconstitution information in our dosage calculation. In our dosage calculation, we use the doctor's order and we use the concentration. And those are the only two pieces that we use in calculating the amount for one dose.